FTC accidental success consists of sub-teams designated by function. Today, when you hear us refer to a specific team, we are talking about one of the function teams in accidental success. We will be starting in one more minute. We are so excited. Welcome to our team's first webinar. As the first robotics team, it is important for us to share our passion of STEM with our community.
During this time, social distancing we reached within as well as beyond the boundaries of Maple Valley to bring STEM to you. This is important to us that you are safe. We brought these STEM speakers to you throughout this webinar.
We are going to start with an introduction from our build team.
Members of the FTC Team Accidental Success. I am Stephen Bohlin.
And I'm Brady Poggioli. We are part of the build team for Accidental Success. Stephen, what's your favorite part of being in robotics?
I think my favorite part of being in robotics would be helping build the robot and program the robot, I think. Brady, what is your favorite part of being in robotics?
I really enjoy building the robot and catting the robot. What's your favorite part of building the robot?
I think my favorite part of building the robot was helping design the intake that we have and helping program the claw to move open and closed. What is your favorite part about building the robot?
I really liked driving it after we finished building it, actually. It was just a lot of fun to have actually finished the robot.
Yeah. I think we have a lot of fun in this FTC team.
Yeah, we do!
They sure know how to have fun.
Maybe the business team should get some drinks too.
Could be fun. Next up is Brady talking to Professor Rob Carter from California Polytechnic Institute.
Welcome. With us today is Cal Poly Professor Rob Carter. Thank you for joining us.
Pleasure to be here.
Can you give us a short introduction as to what you currently do at Cal Poly?
Yeah, sure. I'm a full-time lecturer, so I'm a full-time employee at Cal Poly, and I teach primarily in the Industrial Manufacturing Engineering Department, but I also have a lot of other responsibilities for committee work and that sort of thing. But mostly teach hands-on, learn by doing laboratory courses at Cal Poly, and mostly first and second year students in metal casting and electronics manufacturing areas.
That's cool. What other careers have you done in the past, and how did that lead you to teach at Cal Poly?
Well, in the past, when I got out of school, I worked in the aerospace industry in the Los Angeles area, and I was a materials engineer by my studies, and so I worked in materials and processes engineering primarily for aerospace companies. I worked in both spacecraft and aircraft. Now, it was my desire to move back to San Luis Obispo that sort of made me look at a career change that would make that happen. And so, interestingly enough, around 2001, I left my engineering career in aerospace in Los Angeles area and became a wedding DJ. And because of the destination weddings that occur in the San Luis Obispo County area, I started a business and started doing that here. And then when I came to San Luis Obispo and started that up, I went into my old department and walked around and introduced myself and met the chair of the department and she said that you should come and work with me. I think it would be an interesting thing. And so I said, sounds good to me. I just thinking maybe that I could volunteer or something like that. And so I did. I helped paint a room. I helped move equipment, and then eventually it led to a teaching job. And then I went from the materials engineering department to the industrial manufacturing engineering department because they had metal casting and it seemed to be a good fit, and they had a person who was teaching that who was going to be retiring. So I've been there now about 10 years. So that's kind of the short story.
That's cool. Uh, what is your STEM story? What sparked your interest in the STEM field?
Oh yeah, so when I was young, I always liked math, and so and that when you're good at something and you like it, or if you like it, you're good at it, or vice versa. That was always a strength for me. And then when I got into high school, I sort of was interested in chemistry and atoms and that sort of thing. And I saw the smart kids, they were all signing up to take physics and classes like that. So I took that. And so I just kind of naturally started talking to other people. And one of my close friends was a year ahead of me in high school. And when he graduated, he went to Cal Poly. And he said, you should do that. You should go to Cal Poly. And so I applied and I got in. Now I don't think I could, not with my grades anymore. I couldn't get into Cal Poly now, but luckily I did get in. And so it was really because I always liked math. And so I applied as a math major, knowing that I probably wanted to do engineering, but I had no idea. I really didn't know much about what engineers did, but I knew that all engineers take math. And I learned math, physics, chemistry, so there's a bunch of core classes, basic classes that everyone takes. And so I could figure out what I wanted to specialize in when I got there, and I did.
Okay. What keeps you passionate about your job? What is your favorite aspect of your job, and why have you stayed with it?
Yeah, this is a great question. So, I have to say, probably the most compelling thing that I get to experience on my job is working with young, smart people and watching them go from high school young adults to a little bit more mature young adults. And they're very smart, but I see myself kind of a little bit sometimes the way that they were. But now that it's been so long, it's not as easy as it once was. But that's part of it, is working with young, smart people. The other thing that's probably most attractive about teaching is that you have some flexibility in your work schedule. So you don't have to work 52 weeks a year or 50 weeks a year. You get a lot of time off to do other things. And so I mentioned the DJing thing, so I still do the DJing thing, and I try to do that during my times off. So you can kind of have multiple careers, multiple interests going. So that's a plus for teaching. And Cal Poly is a great place. San Luis Obispo is a great place to live, and I think that I found a home that keeps me there working as a teacher, as hard work as it is, because sometimes during the week almost feel like you're on 24/7, but it's a pretty good life. And so I have considered going away from teaching and back into industry, but I don't want to move outside of San Luis Obispo, and so this is probably the best job for me, and that's probably why I stay. Yeah.
So you do multiple things then?
Yep. Tomorrow I have a wedding. I am DJing. Next Saturday I have a wedding. I am DJing. I am a wedding DJ.
What recommendations do you have for someone entering the industry?
Well, engineering is really fun, and you make and build things that help people in some ways, and also you can earn a fair living so that you can afford to live in a nice place if you find your niche. I think it's also important to find people that that you can relate to, and so that you can get through the tough parts of the studies. So you know you're not in it all alone. You're together with other people working hard to get through it, and you kind of go through that period with your hopefully support group. And I'd say that finding your passion is really important. And if you find something you're passionate about, it doesn't seem like work, and you get paid pretty well. So if you got to a place where you at least know yourself well enough to know you like some of the math and the sciences that you've been exposed to, then maybe considering an engineering career is something to put some attention on and ask questions about, and ask other people. Try to find people who are engineers or who teach engineering, and talk with them like we're talking, and see if there's a fit for you, because that's kind of what I did in high school, even when I really didn't have any specific ideas of where I would end up, what it was going to be like. It was a little bit scary, but somehow deep down inside it just felt like it was the right place for me. And it wasn't easy along the way, but I just kept, if I fell down, I got back up and kept moving forward. So um, it can make for a really great life.
Okay. What was your favorite part of working in the industry?
You know, I like to work with my hands, and opportunities that I had from my Cal Poly undergraduate experience in research in graduate school. I got to work on things with my hands. And the opportunities that I had in industry and the various jobs I had in aerospace, when I got to work with hardware, that was definitely the most fun, as opposed to working on my computer, writing reports, or going through data or something. Working with my hands was a highlight always. And I'm glad to say I got to do that a fair amount.
Okay. Yeah, it's always fun to be more hands-on than just like from afar.
It is for me.
So why did you choose aerospace?
Well, I grew up, there was a lot of aerospace industry. It was in the South Bay area of Southern California. So you had all the big aerospace companies, Hughes and Northrop and TRW and Lockheed. And, I knew that those were people that dressed a certain way, that, kind of dressed up a little bit, sometimes wore a tie, usually slacks, and they just looked smart. And I just saw that, and they drove a reasonably nice car, they lived in a reasonably nice house, and it just seemed like, okay, that's a way to have a reasonably good life. And so I saw I could see myself, doing that, not knowing what it took to actually do it. I didn't know that, but I saw them and I thought, yeah, I could see myself there. It kind of started with that.
What is one of your favorite projects that you've worked on?
Well, there were some interesting satellite projects that I worked on. Just seeing a complex bunch of electronics and structures, and the way that they test it, going through into a vacuum chamber and cycling it through high and low temperatures to simulate orbiting around the Earth, and making sure that it's going to function correctly throughout all those cycles was an interesting experience. I also had some experiences doing some sort of basic research on how to make materials stronger at high temperatures. That was interesting. My research in graduate school, which was making metals, looking at the behavior of metals and predicting how they would behave, different alloys would behave if you change their compositions, was interesting. And then I'd say sometimes working in teams and appreciating other people's abilities was another aspect that I found interesting as far as industry goes. And I guess a little bit of that continues here today. as a teacher. I'd say the most interesting aspects are, well, the freedom of being able to kind of create my own ways to talk about materials, and more importantly, try to have students talk about the materials that we're discussing, the technology areas, setting them up to be challenged but also be successful. It's pretty challenging to do that successfully with a very wide range of abilities and backgrounds and experiences. So that's one of the bigger challenges, and I'd say that's also rewarding and interesting too.
Well, then, what other engineers do you work with?
Oh, mostly other manufacturing engineers today, unless I'm doing committee work. Now, committee work is interesting because I do get to work with people from other departments in the College of Engineering. So seeing what they bring, their perspectives is interesting. At first, I did a lot of listening to hear their perspectives, and now I feel comfortable communicating my perspectives. And it's still a bunch of engineers working to solve a problem. It may be the case that the personnel document needs updating, or we don't feel that we have a diverse and inclusive enough feeling on campus among students, and so we need to figure out how to improve that. We have to identify the problem and figure out ways to measure whether or not you have success. It's still kind of engineering problem solving in a way, and but those are interesting now. So mostly I work with manufacturing engineers, but I get to work outside with other people with other backgrounds and disciplines too.
Okay, thank you for your time.
Okay, well, it's been my pleasure.
Wow, it is so cool how he gets to pursue his passion with the music as a wedding DJ and work in the STEM field as a Cal Poly professor.
Hello, this is Brayden. He is the lead strategist for the accidental success. He is very quiet, as you can see, and he is very smart. He is the one who helped us figure out how to configure the robot properly.
I know Braden talks more than Steven says he does.
Today I'm interviewing my dad, Brian Stewart, who works as a manager at Boeing. I'm going to be asking you some questions today.
Okay.
What is your STEM story?
My STEM story, I would consider myself what you would call an accidental engineer. And I'll tell you a little bit about why. So, growing up, neither one of my parents formally got an education. Neither of them went to university. I was the first one in my family to do that. And in fact, you're in what, eighth grade now?
Yes.
And you're in algebra. And I could remember as I started to get further into math as a kid growing up, I'd bring those things home, and kind of math wasn't a topic that was well known once you got out of basic math in my household. So reflecting back on that, this wasn't this thing that was around me, and certainly as I got into high school and into college. But growing up, I was certainly influenced by my family. My dad spent 30 plus years at Boeing, not as an engineer, but working in research and development. And so I would learn a little bit about stuff that he was doing at work, which really interested me, and hearing from his friends at work. I can remember one time my dad was working on a job that the things they were building as part of a team were going to be in the payload of the space shuttle. And this was back in like the early 90s. And that floored me to know that my dad had done something that was going to fly with astronauts into space. And those were certainly influenceable things for my childhood. As part of, my dad had learned through computer design at Boeing, and he ended up having a side business, which I started learning a little bit about in 9th and 10th grade. And I learned about computer-aided design. And so there were certainly things that influenced me with that technology. I grew up on a Macintosh, learned Unix, learned Windows operating systems, all early 90s, late 80s, early 90s. And so I was certainly influenced with technology at an earlier age. Not like what you guys get to see with smartphones, watches, Lego Mindstorm, all of that. So it was certainly different when I was a youth. But when I went on to college, the first, what I was really going to study was business management, business administration. And so I spent about 2 years learning that. And step one back further, back in high school, I didn't really have a passion. I didn't say I knew I wanted to be something when I grew up. And so when I went on to college and I chose this path of business administration, business management, I had spent time the first couple of years doing my prerequisites for my program. And I was doing the science and math still, trying to learn, what was of interest to me. And so taking the physics classes, taking chemistry, taking biology, taking some of the advanced math classes, I then pivoted and realized, I'm really interested in more of the engineering side. And so it was through that discovery process that this really stuff started to click for me. And at the end of the day, I just like solving problems, and it was something that intrigued me. And so that's why I kind of consider myself an accidental engineer. And that's my STEM story is, it was something that had evolved over time. It wasn't something that I had a tremendous amount of background in, but it certainly piqued my interest. And then when I went into college, I ended up going the electrical engineering path, and certainly glad I did.
What did STEM look like for you at your age?
At your age? When I was your age? Yeah. So if you think about where you guys are, I think STEM is very important. Science, technology, engineering, and math. The focus on it in education is very critical. And having been someone who went through an engineering program academically into the working world of seeing what's required out there, we don't have enough of those people. We're not producing enough as a country. When I reflect back about your age, when I was your age, so if you're in 8th grade, I was in 8th grade, it was very common for me growing up to have things like sports games. I mean, it was baseball, basketball, football. Those were the things that you could do extracurricular outside of school. There really wasn't something else that was focused on any offering that was out there for any science type curriculum outside of school. Really, the only things you got were the science projects that were through school. But there was never this focus on something that was producing more interest in it in an extracurricular fashion, like you guys are with robotics. That didn't exist when I was a kid. And in fact, the first Lego Mindstorm, I think, came out like in the mid-90s, 96. And so I was in college at that time. And, I could remember one of the engineering freshman classes that we had, and I was a teacher's assistant in the engineering program. And when we would bring students in, we would teach them different aspects of engineering, mechanical, electrical. I think we even did a little programming. But most people, they see the Lego Mindstorm and you could actually apply something. There was some logic that was applied to make it move, maybe a series of inputs that would, do something to make it a different outcome. But there was nothing like that existed when I was your age. So I'm hopeful now that you guys, knowing that you've got smartphones, you've got smartwatches, you've got a computer in every room, all of those things lend itself to more interest and hopefully solve problems to get people more interested in STEM.
So did they have robotics clubs, or did they have like robotics clubs like they have now?
No, not at all. Didn't exist.
No, didn't exist.
Yeah, because there's none of that stuff was around. There weren't these little. You think about a computer. You got a computer on your wrist right now. Computers, when I was your age, were a desktop this big. And how do you get some sort of a CPU or processing unit onto a small little robot? That didn't exist back then like it does today.
Okay, so what keeps you passionate about your job?
For me, I think it comes with accomplishment, certainly working in teams. And I have been very fortunate over my career, either as an engineer or as a manager leading people. Through the work I do at Boeing, I've gotten to do some really interesting things. And all of them are focused on solving big problems. I spent a number of years, several years ago, as part of a bigger team that was implementing a brand new production system. And it was, the whole goal was to help make the mechanic's job safer, more efficient, and produce a high quality product. And that was a project that lasted for like 3-4 years, from concept to getting it into the production system. But all of it, when I reflect on like the best time I've had, it was all around that team working on this big goal to go complete something and accomplish something. So to me, what gives me passion is being able to work with large teams, small teams, and being able to achieve big goals. Because there's challenges like any project, even for you guys on your robotics project. You're going to try to go solve something, and you're going to find that you're going to run into a stumbling block, and there's something preventing you from getting there. But you guys all will collectively work as a team to go solve that. And once you've done that, and you've accomplished that when it's over, to me, that's the feel good. That's what keeps me desired at my job and keeps me moving forward on my job.
What's one of your favorite achievements?
One of my favorite achievements? Professionally or
Professionally, yeah.
Favorite achievement. I guess I would say it still goes back to the last kind of question, which achieving something with a large team of big problems to go solve. That's probably one of my greatest achievements. I've had many different things that I've worked through my career at Boeing or outside of Boeing. Even in my first career, I was learning things, but to me, I guess when you say achievement, it goes back to, again, that passion of being able to solve big problems.
What's the most fun part of your job?
The most fun part? This is something, I've been in my career now for 20-some years. And if you asked me that question when I first started after college, it would probably be a different answer than it is today. I haven't done, quote unquote, the traditional engineering role in maybe 9 or 10 years, because I've been in management for that long. But just because I left that job as being what I'll call an individual engineer solving problems into more of a leadership role, my passion now, or I should say fun that I get, is being able to help people do their job better. So having been worked in manufacturing for the past 15 years, what really gravitated to me was this thing called lean manufacturing, this concept of doing something so efficient. And it's, whether it is whatever you do, and you'll see that with me at home, I often think about things of efficiency, unfortunately, just who I am. But how do I, as a Boeing leader or as a leader or whatever I do, help other people do their job more efficiently or effectively? So if you are an engineer, how do I help you do what you want to achieve? Remove roadblocks that are maybe preventing you from getting where you want to go. And so I think I think of myself as more of a coach now in the leadership role. And that's where I get the most fun out of my job, is by being that. If I can help you be better, that's a great reward to me.
So what did your job look like when you started out at Boeing versus what it looks like now?
So when I first started at Boeing, I was hired in to become what's called an equipment engineer. So using my electrical engineering background, I hired in and supported one of our production lines in Renton. And my job was to take these big machines that help assemble part of the aircraft and automate them. So what a lot of what you guys are doing in robotics with smaller concepts, I was doing on large scale. And that was my sole job to begin with. And that was so much fun because, again, I was a control engineer, electrical engineer. I had to make systems move. So I had to have a series of motors, of drives, hydraulic systems, all these things working together in certain sequences using programming to go build products. And that was so fun. And that was my job to begin with at Boeing. My job now is I lead an organization of engineers to go help provide facilities, production system, floor space requirements to go help build a lot of our Boeing products. So my job now is more not just on one airplane product line, but really spans all of Boeing.
Would you change anything when you started out at your job to now?
Would I change anything? No, because everything I have learned over my career has shaped me. Whether it's been hard projects, easier projects, the harder projects really influence you as a person because you will hopefully grow from them. You'll learn the bad things that happened or the not so pleasant things. And all of that helps make you a better person in the next job. There are people who, once they hire into a role, that's the role they want for the rest of their lives. That has not been who I am, as just kind of I'm wired. I find many interests, just as you'll see outside of home, home environment, I do a lot of different things. But that suits who I am and my personality. So everything I think I've learned along the way, especially my professional career, has only helped build on who I am as a person and hopefully as a leader.
What do you use that you learn from work out when you're not working?
Well, maybe you might be able to answer that better than me because obviously I'm your dad, and so there's the parental component of it. But certainly you working on homework and math, there's those things that I've learned over my skills to go help hopefully teach you. I certainly hope not only just being your dad, but I hope that I'm also a coach to you to help you achieve things you want to achieve in life, whether it be robotics, whether it be STEM, whether it be music, whether it be whatever it is you want to go do, I want to go help you achieve that. So I think the thing that I've learned most from my career is this desire to want to go help solve problems and help people be better.
You said STEM. There's not many robotics programs when you were a kid, or if any. What do you think STEM means looks like today?
Yeah, there were certainly, we talked about, there was not any, really, the technology wasn't around when I was a kid where you could have robotics in the way that you guys have it now. To me, I think the idea of robotics, it's one element of STEM, right? Because STEM obviously cascades many different areas. Robotics is a platform that allows you or other people to go really learn about problem solving, teamwork. It's not just about the robot, but it's all those things that the robot affords you guys to go do. It's a forum, it's an environment, it's competition, it's learning about how to be a good leader, how to be a good teammate. There are so many foundational elements there that are just not the technology piece that you guys help solve for. I think that always, if you're, if any student or youth is exposed to something like that, where it allows them this creative outlet to go learn something, and especially since seeing the robotics team you're involved in last year and even this year, the teaming aspect is a big part of it. Roles and responsibilities, from strategy to design builder to programmer. They're all things that are elements that are required to go provide this end product. That's kind of, to me, is almost secondary, that product. Yeah, you guys are gonna go learn something, you're gonna experience, you're gonna build something, but it's all those other tools you guys are learning that are really foundational for you to go help you later in life. I mean, in your life today and in your future life. Making that stuff more accessible to many other team or other people, other youth, I think is probably the next biggest element out there. So as a parent, how do we get more of that to different demographics, different socioeconomic, different areas of the world? How do we make sure that that stuff continues to perpetuate and grow? So I know we've got this great system here in Maple Valley. We need to see more of that, I'll say, across the states and across the youth programs out there, because this will promote more people, more thought into STEM, science, technology, engineering, and math. All of that will help foster this desire to want to go do it, help grow more people who are capable of it and really interested in it. And I think that's what's really great about STEM today and where it can go.
Did you catch that Mr. Stewart is an accidental engineer?
Yeah, and we're accidental success.
Well, he is successful in STEM.
Maybe we're onto something with our name.
There is nothing accidental about the next interview. Hello.
Okay, so Anna, what is something you enjoy about robotics?
So what I enjoy about robotics is it's a place where it's a thing where I can use my creativity, towards something, and I can help people, and I also like about the social factor, like I can interact with a bunch of people who are interested in the same things I am interested in also, and that's what I like about robotics. And so what I want to ask you is how did you get into STEM?
Well, I really like science, and And my friend and I were talking one day, and he was telling me about this really cool robotics team. And I was like, I wonder if there's one at my school. And so I asked my school about it, and they're like, yeah, we have a robotics team. Do you want to join? And I was like, yes, please. And so a lot of my friends actually were um, doing robotics, and so it was a chance for me to hang out with them as well as do something that I enjoy.
Yeah.
So what do you like about STEM?
So like what I like about STEM is that you anybody can join STEM. It doesn't matter who you are, what you look like, where you're from, uh how rich or poor you are. It doesn't matter. You can do STEM. STEM is it's very fun. You can learn a lot of things, and it can also, you know, build a, it can help you get a job in the future. It can also help other people who are in need too. So yeah, this is why I like STEM. And yeah.
What's funny is that's actually the reason why I like STEM and robotics so much. They don't discriminate against different people. They just have fun. They have fun as they're doing something they love. And I
Yeah.
like that. And what got you interested in robotics?
It was mainly through movies like RoboCop, Terminator. And my dad showed me those movies, and I was like, I want to build those. Um, and then I realized I couldn't, but then there was something that, and then I realized, oh, there's STEM, and so I started playing with like Vex, like like Lego, the Lego robotics, and it just built up my interests like a lot. And I also, then I realized there was programming. My dad also introduced me into that. And also, I also like that, but I realized there's also a business aspect to STEM as well, and that's what I'm really interested in, and that's how I got into STEM.
So what does STEM mean to you?
Um, STEM is what does it mean to me? STEM to me, what STEM means to me, again, it's a never-ending pit of learning that is like you can learn almost you can STEM. It's like a bottomless pit. There's it's you can never master STEM because there's always something new coming out. There's always something new to learn. There's always updates in technology, always some new updates in science, and math. The only thing that doesn't get updated is math, because that's it. But the rest, engineering, science, technology, those are always getting better and better. So there's always something new new to learn from STEM. And that's why I like STEM.
So what do you want to learn? Well, what do you want people to know about our team?
So what I want people to know about our like team is that we are a rookie team. We just This is our first year in FTC. I want them to know that even though this is our first year, we still have some background knowledge. We came from FLL, and what I want people to know is we have smart and capable people on our team, and we're diverse. We're fun. We're inclusive. We understand gracious professionalism, and most of all, we have fun. That's what I want people to know about our team.
You did a great job on that video.
Thanks. So did you.
Coming up is Stephen interviewing Andrew Bohlin.
Mr. Bohlin is working at Blue Origin, which is located close by in Kent, Washington.
Hello, my name is Stephen Bohlin, and I'm with the FTC team Accidental Success. This is my dad, Andrew Bohlin, and we are going to talk a little bit about how his career leads to STEM. Hey, Dad, can you give a brief introduction of yourself?
Yep. So I'm Andrew Bohlin, and I'm a professional engineer in the states of Texas and Washington. I graduated from Texas A&M University at Galveston in 2002 with a Bachelor's of Science in Maritime Systems Engineering.
What is your current job title and responsibilities, and how do they relate to STEM?
So currently I work for a company called Blue Origin. It's a reusable rocket company. The responsibilities that I hold there are for structural engineering analysis for the ground support equipment. And currently we're working on the new Glenn program. That is for a large orbital rocket. So the responsibilities that I have in particular are for finite element analysis and reviewing of other engineers' work. So a lot of that relates to STEM all the way through for science, technology, engineering, and math. It requires all of those components to do my job.
Okay. So how long have you been involved in STEM positions within your career?
So I've been in STEM positions ever since I graduated college, and to some degree a little bit before then as well. So I've been in my career for 18 years. And I've done, as I mentioned in the previous question, I've done a little bit of each one of the tenets of STEM.
Okay. So how did you decide to go into STEM? How did you decide to go into a STEM-related career?
So when I was young, I had a passion for animals, and I really, really wanted to be a veterinarian. And so I started looking at the programs for Texas A&M, and I was really interested in their sister program at Tarleton University. So I was on a path to go into animal science and veterinary medicine. And so that's what really brought me into a science type career. Eventually I moved out of that once I got into college. The program wasn't exactly what I thought it was. Certain aspects of it were a little bit harder than I anticipated, but I still had a passion for doing things in science. So I looked into the civil engineering program at Texas A&M, and eventually I went down a different path, and we'll probably discuss that a little bit here in the next few questions. And so I started out in one program and changed my mind and still ended up in a STEM career.
Okay. So can you discuss some of the accomplishments you have made because of your career choice?
So some of the accomplishments I've had over the years are, as I mentioned, I'm a professional engineer. To become a professional engineer, you have to graduate from an ABET accredited program in college, and then you have to spend, depending on the state, you have to spend 4 years as an apprentice, basically, as an engineer in training underneath another professional engineer. So I did 4 years of studying underneath other engineers, and then I sat for an exam, which gave me the certification and the licensure to be an engineer in the state of Texas. So that was a really big accomplishment for me. It's kind of like a doctor going in and doing, their residency. So that was a big accomplishment. And then another big accomplishment, along with the help of some of my colleagues in the subsea industry, I came up with a patent. And the patent was for a process on installing subsea structures on the seabed. And the problems that we were coming up with is that to put structures on the seabed for the oil and gas industry, we were getting into deeper and deeper waters, and it was harder to hit our targets and get exact locations of where we were putting our manifolds and our pipeline end terminations and things like that. And so, like I said, with the help of colleagues, we came up with a process and an idea on how to anchor a subsea structure to a pre-installed foundation on the seabed. And so these are some of the accomplishments that I've had throughout my career.
Oh, okay. So tell us some of the more challenging projects you've had through your career.
So one of the first most challenging projects I had was when I was a real young naval architect. I was working for Alan C. McClure Associates, and we were working on the Coro Coro project, which was off the coast of Venezuela. And it was in really shallow water. And some of the challenges that we had were that we were trying to moor a floating in production offloading facility. Basically, that's a really big ship that stores oil and gas and waits for tanker ships to come to it and offloads to them so that they can take them on shore. The problem we had was we were in really shallow water, and the depth of the ship was almost as deep as the water was. If you sank the ship, you could still walk on the deck and you'd just barely be knee deep in the water. So I had to come up with a mooring system that would keep it on station, but at the same time keep the ship from hitting bottom during a heavy storm. So that was a really challenging one. I came up with a really good array. It was verified by my superiors and the engineers that were working above me, because at the time I was in engineering training. So that was a real fun one. One of the other ones was when I got into the subsea industry. I worked on a project called Lucius for an oil company in Texas called Anadarko. And they asked that we come up with a subsea infrastructure system that had 21 structures on the seabed, and they were of 3 different pipeline sizes. All of them were pretty unique. There may have been a couple of structures that were very identical to each other, but for the most part, they were all across the board. I came up with a modular idea of the 6-inch, the 8-inch, and the 16-inch pipeline all falling into a category of 4 categories of designs. So that one was pretty difficult because they were asking for something to be done in 4 months, which typically takes about 6 to 8 months per structure to design. But with my knowledge and expertise and the help that I had from my colleagues, we were able to come up with something in the time frame that they were requiring, and we turned a very complex issue into a very simple issue for them. And now that I'm working in the aerospace industry, we're working on the transporter erector for the New Glenn program. Okay. The New Glenn program has its own challenges for the ground support equipment, because we're essentially creating a tower that will hold the rocket while laying down, and it has to be approximately, the rocket is going to be close to a 36-story building, and we have to roll it out towards the launch pad from the integration facility, hook it up on the launch pad. So there's a lot of mechanisms that are going to be attaching to it, and then it has to be pushed up onto the launch pad while holding onto the rocket. So it's got interfaces between the tower and the rocket. And so there's a lot of complexity going on in this. And that whole tower is going to stand it up vertical on the launch pad the day that we go to launch. But yeah, so that's a big challenge, because you're taking something really big and you're holding on to something else that's really big, and you're upending it onto a launch table.
Okay. So, what keeps you interested in what you do, and what is the best part of your job?
So across the board, from all the jobs I've held during my career, we had in offshore, we were always coming up with new and innovative ideas. I actually have some examples back here of some of the structures that we worked on. So this is an example. This is a small 3D print of one of the subsea facilities that we had to design, engineer, and create. It had to be installed vertically from a ship, and then it had to go down and hinge and lay flat on the seabed, and then we had to lay a pipe away from the structure. So this was a really interesting job that I held, and I did this several times, made several of these, and they all had different mechanisms on them. The fun part was coming up with all the new ideas. Everything had, just about every project was unique for some reason or another. The water depth, the pipeline sizes that we were dealing with, the pressures that we were dealing with, Every single one was a unique design. Almost no two of these on the seabed are alike today. So that was fun. We always had to come up with new locking mechanisms, and what you see here is some innovation that both me and my colleagues and counterparts all came up with simultaneously at some point or another to make the mud mat work like a snowshoe on the seabed. We had to make a mat, right, like this, that would distribute the weight of the structure. Some of these structures are 25 tons. Some of the structures that we designed were 200 tons. So we had to come up with a way to make this mat big enough. However, it had to fit through the working station on the ship. So to do that, we had to make it fold up. And when you make it fold up, you have to put locking mechanisms in there to keep everything together and make sure that it doesn't fold the wrong way or unfold when you don't want it to. So those were some of the fun things that we had to come up with.
So what is a mud mat?
So the mud mat is the bottom part that I was just showing you. So it's kind of like when you go walking in the snow, right? Your foot, if you were to just put the structure here, the structure is a tiny little piece right here. If you were just to put that onto the seabed's really soft mud. And so you have to understand how the geotechnical side of things work. If you were just to put that onto the seabed, it would sink. You wouldn't be able to see more than half your structure. It would just fall right through the mud, just like if you were to walk through the snow with regular shoes on. You would just pierce the snow with your feet and you wouldn't be able to move anywhere. Well, the same thing would happen subsea. If you put this structure down and it didn't have this big plate on the bottom to spread its weight onto the seabed, then it would just sink. So the mud mat is there to keep all the structure above the seabed so that you can go in with a remotely operated vehicle and attend to all of the mechanisms that you needed to, all the valves and all the hookups. So that's what a mud mat does.
Okay.
Okay, and then let's see here. In the aerospace industry, the fun thing is being able to see the product, right? So right now I'm able to go to a shop floor, or when we actually have launches and things, I'm able to show my family and my friends what we're doing. With the subsea and offshore industry, I wasn't able to do that because by the time we got it all built, it was going onto a boat and it was going to be installed below the water. So most of what I designed or engineered and had built was never seen by any of my friends or family unless I took a photograph of it.
Okay. With the jobs that you have held, how has STEM directly applied?
So, as a naval architect, I had to do a lot of math. So I was responsible for designing some of the mooring systems, like I was telling you earlier. And we had to take into account wind. We had to take into account waves. We had to take into account current. And hardly any of which all went in the same direction. So I'm looking at a ship that's got a heading going one direction. The waves are hitting it from one side. The wind is hitting it from another side. And the current is going in a completely different direction. Okay. So there was a lot of math, a lot of coordinate systems I had to work with. So that was, for a young engineer, for a young naval architect, that was a pretty daunting task. Some of the other things that we looked at were frequencies of roll motion and heave and pitch and yaw of the ships that we had to design. I was involved in a joint industry project for a study on how to reduce the amount of roll on a ship. Okay. Some of the things that we came up with are the use of fluids, passive and active, moving from one side of the ship to the other side of the ship, and that would reduce the roll. So if you had a ship that was rolling with a frequency that was too uncomfortable, what you could do is you could put water into a tank, and depending on how much you needed to change that frequency, you could make it passive. So as the ship rolled to the left, gravity would pull all the water to the left, right? Okay. And then as the ship rolled back the other way, that mass from all the water had to move back over to the right. And that would slow down the roll of the ship. Now, if that wasn't enough, then there was an active system. And the active tank would actually push all the water from one side to the other. So there's a lot of math, there's a lot of engineering that had to go on into the naval architecture side of things. So we had to look at ship dynamics and both free floating and while it was moored. And then for the subsea engineering, we installed structures and pipelines on the seabed like I've discussed. So a lot of the work that we did was in the Gulf of Mexico and off the coast of Africa. The water depths and installation procedures that were required, those were all new ideas. They were all innovative. We were always coming up with something different on every project. So there's a lot of engineering and technology that goes into those industries.
Okay.
And right now I'm working in the aerospace industry for ground support equipment. We're designing the handling equipment for the brand new rocket that hasn't even been designed yet. So there's a lot of challenges there. There's a lot of math that's going on and a lot of engineering and technology. So.
Okay. So how does STEM apply to the company you currently work for?
So Blue Origin, as I mentioned, is a reusable rocket company. We have two programs that we're pushing forward right now. The two main programs are the New Shepard and the New Glenn. So it's our founder's idea that one day we're going to have millions of people living and working in space. He knows that this is going to be a multi-generational task. It's not something that's going to happen overnight, tomorrow. It's not going to be done anytime soon. And he realizes that we're going to have to build a whole army of people that have a passion for science, technology, engineering, and mathematics. So while we work and build the infrastructure to get into space and beyond, we're developing new processes, we're developing new materials, and we're innovating new mechanisms, and all that kind of stuff. So this will require a wide base of knowledge in all aspects of STEM to pull off the accomplishments that Blue Origin is really looking for.
Okay. So when you were in school, what was it that sparked your interest in STEM?
So yeah, when I was in junior high and high school, there wasn't a formalized STEM program, or we didn't have a whole lot of robotics programs like you do today. You gotta remember, this was 25 years ago. So all of that's come up in the past couple of decades. So what would really get people like me involved into STEM was, first off, I said I had a passion for animals. I wanted to help them. I wanted to be around them all the time. So science was already on my mind. But it was certain things like watching Star Trek at night. We had 2 or 3 different Star Trek series that were playing while I was growing up and I was your age. And so I would sit there and watch those while I did my homework, right? And seeing those kind of inspired you and made you think a little bit. And it's kind of funny because the founder of Blue Origin, that was kind of his inspiration as well. So it was just a lot of things that you would see on television. One of the things that I did when I was in high school was I got involved in academic decathlon. That was probably the closest thing in our school that we had to a STEM program. And it reached across all aspects of learning. Academic decathlon, if you're not familiar with it, it gets you involved in all of these aspects of science, technology, engineering, and math. And it also goes into the arts, and such as music. It also goes into public speaking and debates and things like that. So it was more of a well-rounding program, but I wouldn't be as interested in the math and the science and the engineering as I am today if it wasn't for the programs such as academic decathlon and for the 2 coaches and teachers that we had for that team. One of them was an English teacher and one of them was a physics teacher, and I attribute a lot of my interest to what I'm doing today to those 2 teachers. And there were actually several other teachers in my high school that contributed to my interest. I had a chemistry teacher. She was a really good teacher. She saw that I was struggling with chemistry, which, by the way, is part of the reason why I figured out I wasn't going to do very well in animal science. And so, but she was a really good teacher, and she kept my interest in the science part of it. My physics teacher, who was also an academic decathlon coach, he kept me interested in it. So there were a lot of little contributions like that that play a bigger role, but you don't realize it until later on.
Yeah. Okay. So what advice would you give to students who might be interested in going into a STEM-related career?
So what I would say is get involved in the programs that involve math and science, things like that in your school. If you have a robotics club, try to get involved into that. If you have some type of technology club or a computer club or anything that might spark your interest, if it's just something you think you might want to do, I would recommend going ahead and trying to get into that. Aside from the school activities, once you turn the age where you can go work, instead of just assuming that, oh, you're going to have to work at the grocery store or work at McDonald's or wherever the case may be, look at trying your hand at some of the trades. Go out to, say, maybe there's a local machine shop, maybe there's a local mechanic shop, or a computer store that does computer repair, or somebody who's doing a startup for some software or something like that. Try to get involved with those types of companies early, so you can find out if that's really what you want to do. And if it is what you want to do, then they will encourage you as much as they can. And for larger companies, there's a lot of scholarships out there. If you can get involved with, say, Microsoft or a large tech company like that, like Google or Facebook or YouTube or any of those guys, a lot of those may have scholarship programs, and a lot of them may be looking for interns. But it's never too early to start that stuff. If you start looking at it in high school, you have a better chance of developing your skills into those fields and getting involved into STEM that way.
Okay. Well, thank you for tonight.
That would be so cool to help take a reusable rocket.
We're moving us closer to making Star Trek a reality.
STEM careers are really exciting.
Let's meet another member of our build team.
This is another member of our build team, Eli. Say hi, Eli.
Hello.
Eli, what's your favorite part of being in robotics?
My favorite part of being in robotics is probably working with the team and just having a good time working on the robot.
Okay, what's your favorite part of building the robot?
My favorite part of building the robot is making custom brackets with hammers. And also, I really like working with the team and assembling the robot.
Okay, it's nice talking to you, Eli. Bye.
Nice talking to you. Bye.
They are having fun while social distancing.
That is something that our team has been working on since last spring. How to bond, learn, and grow as a team while social distancing.
I think we've done a pretty good job.
Up next is Eli. Eli is talking to two seniors at Cal Poly.
I'm interested to hear about the start of career in STEM.
Thank you for joining us. We are with Balthazar and Jason, who are fourth-year manufacturing engineers at Cal Poly and officers for Society of Manufacturing Engineers. What are your guys' majors and minors?
Jason, you want to go first?
Yeah, I'll take it away. Let's see. So I'm a manufacturing engineering student, and I'm just getting my bachelor's degree, which means I'm in school for 4 years, and then I'll be leaving Cal Poly, and then I could come back for one more year and get my master's, which just kind of looks a little nicer, but a lot of engineers just kind of do 4 years. So that's where I'm at. I have no minors.
All right.
So I'm pretty much on the same track. I'm a manufacturing engineer. However, I've got an entrepreneurship minor. So I'm kind of into product development, prototyping, stuff like that. And then as for staying an extra year and doing a master's, I'm kind of still figuring that out. It's not an easy question to answer, so giving it some thought.
All right. What are your guys' STEM stories? How did you pick your majors or minors?
So actually in middle school, I was a part of my engineering group in 7th grade. And basically we just made like little popsicle stick bridges, or we did an egg drop test and a lot of like fun little labs like that, just using like basic physics. And I really got kind of hooked on it. So I had some Cal Poly students actually come to my class, kind of similar to this. And they talked to us and just told us how great engineering at Cal Poly was. And I was like, that's what I want to do. I'm going to go to Cal Poly and be an engineer. But I didn't really know what I wanted to be yet. So I went into college, not really knowing what my major was, because I just chose it like randomly in high school. I was like, I think I'll do like manufacturing. Like that sounds cool. And then I came, and honestly, I was a little like nervous at first, not really knowing what to expect. But then I actually ended up really liking manufacturing. It's a lot of hands-on stuff. So if you like to like build things or like Legos or, you know, just like making things with your hands, I feel like manufacturing is a very good major.
All right, that's cool.
So the start of my story is super nerdy. As a kid, I was kind of like always interested in observing like what was around me, like my environment, to the point at which like my grandma would force me to carry around a watering can because I'd take like a magnifying glass and try to like burn everything to see like how easily it burned and whatnot, and like how long it would take to light. So I was apparently a terrifying kid for my grandma. But in high school, I took like some physics classes and I really loved it. So I realized that math and science was kind of like my strength. And specifically learning how stuff works and how to put things together, which is engineering, was what I loved the most. And so I talked to an alumnus who told me, hey, check out Cal Poly, because back then I was on the East Coast. So Cal Poly was totally off my radar. And so he said, check out manufacturing engineering. It's super interesting and you might like it. And so I ended up going to manufacturing. And in my classes, I had these people like Jason who'd been doing engineering since like forever. And my family is all business. There's no engineering. I'm like the only engineer here. And so I was like, I don't know if this is the major for me because all these people clearly have so much more experience. I'm just like this nerdy kid who knows math and science, and like that's it. I have absolutely no experience. So I actually ended up switching out of manufacturing to biomedical engineering because my dad works kind of like in the biomedical field business, obviously. And I did an internship. And through my internship, I was able to do like hands-on stuff without kind of the stress of like other students and like trying to show off to other students and whatnot. And I realized, wow, manufacturing is the greatest thing ever. It's so much fun. You get to do hands-on stuff.
Yeah.
And as soon as I got back to Cal Poly from that internship, I switched immediately back to manufacturing. And so I've been here ever since.
Cool. So what are your guys' favorite aspects of your major and minor, and why have you stayed with them?
Let's see, is my video still good? Because both your guys' videos aren't working for me right now.
Yeah, you're good.
Yeah.
Sounds good. Okay. I'd say the best part of my major is probably just the people that we get to work with almost. I do like a lot of club work. So I made a Formula One racing car with the Formula One team last year, and I was the steering design lead. So I was making the column, which like attaches to the wheel,
that's
and that goes down to the rack, which like turns your wheels, and it makes you like turn left or right with the car. So that was probably the most fun thing I've done at Cal Poly, the most rewarding. And then I feel like the best aspect of manufacturing is just like everything's always changing. You always have a new problem to solve, something new to build, something new to fix. And it's just really entertaining. Keeps you going.
I'd say my favorite part of manufacturing is both the people like Jason mentioned, in that kind of our department is really special, I feel, in that the professors are close to the students, but also the students are close to the students. And one thing that I feel makes manufacturing particularly special is there's actually very few manufacturing engineers at Cal Poly. I think there's, I calculated around like 70 manufacturing engineers within all years at Cal Poly for the bachelor's degree. So your likelihood of running into a manufacturing engineer outside of a manufacturing class is pretty low, which means when you get all these manufacturing engineers together in a class, there's kind of this special bond of like, there's few of us. So like being together is a special moment. And so it feels like every time that I've been hanging out with a manufacturing engineer for like a work project or whatever, we always get along really well. Like our minds kind of meld together. And just like we get work done, we're on the same page, which is awesome. Another part
Totally,
of manufacturing engineer, another part of manufacturing engineer that I love is just like all the hands-on stuff. At Cal Poly, we get to do welding, casting, machining, soldering, and so you get kind of to try everything hands-on and see what you like best. Personally, I'm not at all like the machinist guy that'll get onto like a CNC machine and just like make a part. For me, I'm more into like the soldering and kind of the smaller, kind of more personal type of work. Jason, I feel, is probably more the opposite, but being able to try all these things, you really get to find what is your part of manufacturing that you love, because manufacturing isn't just like this one thing that you do. Manufacturing goes everywhere. And so that also kind of plays into entrepreneurship in that, for me, being able to make new products is super cool. And so manufacturing kind of teaches you, how can I make this? Because mechanical, I feel, is very, it's very here, I can draw these plans up to make a part. But with manufacturing, you actually know, can I actually make this? Or is it going to cost me like $1 billion because it's just like so specific to make? So kind of like knowing how to translate your dreams and ideals into an actual part is super cool.
That sounds awesome. What did you do for your internship and how did it affect you?
So I worked at Lawrence Livermore National Labs, and that's basically just like a research facility where they do a lot of like secret like government type stuff. So at first I didn't really know what I was going to be doing, and then they gave me my project, and I was working with the nuclear physics department. And so they had all these like old films, you know, have you guys ever seen like the film canisters where they're the rolls? And that's how they used to like play movies back in the day. Yeah, and then they like let the film run. So they had those, but they were deteriorating and just like basically decomposing. So we took those, and one of the guys, he was an Academy Award winner for Star Wars actually. And then he was able to digitize those. And then we took that and we basically like analyzed them through like some software that we were using, used some coding, and we ran some simulations on that. I feel like it really kind of made me expand myself as an engineer, because I've just done a lot of like the hands-on, like kind of like making things, building things, trial and error type stuff. When this is more research and like you know, like idea, hypothesis, development, all that type stuff that you kind of do in science. I feel like you guys might be doing like some hypothesis type stuff in your science classes a little bit. Yeah, so that really kind of came back and I was like, oh my gosh, this is what I was learning in middle school and high school. And we're really doing it here. So it was pretty fun.
That's awesome.
So my internship was with this company called IFM Effector, which I'd never heard of before, and probably none of you have ever heard of before. But one thing that was incredible is they work with virtually, it feels like every single company. Like they work with SpaceX, Tesla, the Boeing company. I mean, those three are like the same thing, but they work with Yoplait, Ford, any big company that you think of, they probably work with. And so what this company does is they sell sensors and automation to these companies to be able to automate their processes. It's like one of the huge things that they do is work with dairies, because you know how milk has to be pasteurized, you have to boil the bacteria out of it essentially. Well, if it's too cold, then the bacteria won't die, but if it's too hot, then the milk actually will have a lower shelf life. So basically they sell sensors and other stuff like cables in order to make sure that companies that automate processes can be able to do so in a cheap and effective way, and then track everything like correctly. And so originally my position was supposed to be as a sales engineer, which basically means it's just like regular sales, like selling t-shirts at a department store. But the reason it's called sales engineering is you're like smart about the sensors and you have to sell it to someone who's not so smart about the sensors. So you have to be able to translate it from a complex topic to a less complex topic. I actually realized that I really wasn't into sales at all, like a week and a half in. And one thing that was super awesome that my boss did is he realized that as well, and he was able to put me kind of on more technical projects. And so one thing, for example, is there are these things called HMIs, human machine interfaces in factories. And basically it's a screen that tells you what all the sensors are reading. And so sometimes it'll just be what the sensors are reading. Sometimes it's more complex and it'll tell you, hey, milk tank 3 is like out of specifications, it's too hot. So it'll give you more information. And so I got to work on designing an HMI. So it's kind of like basically working with boxes, kind of like a PowerPoint, and designing a slide with buttons that people could press, but then also doing all of the coding behind it that would actually kind of connect these buttons to variables and make things happen with like logic. So it's both kind of computer science and also engineering. And so one thing that I made that was super awesome is we're actually trying to sell these HMIs to companies. And so I got to design an HMI where all of the sensor values in it were essentially just totally fake and made up. And my goal is just to make kind of a working example of what it would look like in a factory where you could press buttons and see things happen. And then also raise these things called alarms. So let's say your temperature should never drop below 110. If it drops below 110, then it raises an alarm which says, hey, this sensor has an issue. Please do like X, Y, Z to fix it.
That makes sense.
Yeah.
Yeah, so what do you think made you stand out to employers while trying to get internships or jobs?
I feel like one of the biggest things I've learned at Cal Poly was they have their big career fair, but when you go to their big career fair, it's kind of like the first one's kind of a get to know you. You're just like talking with companies and you kind of want to sound appealing and just kind of like a good kid in general, just so they want to bring you into their company. And then if you're like nice and have like some experience, they'll like give you some information on how to apply, maybe give you some tips. And then once you actually apply, that's when your phone calls kind of come in. And then on the phone calls is when they tend to either grill you about experience you've had or maybe some hypothetical like technical stuff. And then so basically for my interview, I feel like I was being a part of the Cal Poly racing team. I think that helped me out a lot just because they really like the racing students because they're all different engineering majors working on one project and making this one race car. And of course, there's going to be things going wrong that you have to fix or new things that you have to make, issues that you have to adjust. So they really like the kind of racing environment and they hire a lot of students for Cal Poly. I was actually just talking to it's a company called Northrop Grumman, and they were saying they only hire Cal Poly racing students for some of the projects.
I did not know that.
I thought that was crazy. I asked them, I was like, well, like other majors too, right? Like, of course, not just Cal Poly. Like, you want a good spread. And they were like, no, only Cal Poly, only racing students. So I thought that was pretty crazy. Of course, they hire in other departments, other students, like their whole staff isn't just Cal Poly. But just this one sector, they said, we really like Cal Poly racing. So I thought that was really interesting. But it's kind of hard also because I feel like in some internships, you're not going to get everything. I think I applied for maybe over 20 internships at Cal Poly, and I got my one at Lawrence Livermore. So you just kind of have to keep trying and just putting out your feelers for everything that's around you. And maybe one will land, maybe one won't, but you just kind of keep trying and you just go through the process. I had a couple technical interviews where they were asking me different like compositions of metals and different safety factors and all these hypothetical questions that I'm trying to rack in my brain. And I just had to tell them, sorry, I can't like do that math in my head right now, or I don't really know what process you're talking about. And it's kind of hard going that route also just because you feel kind of let down afterwards. But I mean, you can only kind of go up from there, I guess, you know. things can only get better.
So I got really lucky and I actually only applied to one place, and then that place said yes. But if they hadn't, then I would have been in the same position of applying to 20 places. But I feel like it's boiling down a lot, but I feel like two really important qualities would be curiosity and then, in a way, honesty in terms of people skills. So like two things that my boss really liked about me that kind of like highlighted me as an applicant was I was really curious. I told them I know nothing about sales engineering, but I want to explore what sales engineering is about. I don't know if it's what I want to work for, like once I actually get a job, but like that's what internships are for, is to get experience, to figure out what you like. And essentially I told them that that's what it is. And that also plays into part two, which is kind of the honesty of being honest about, I don't have that much experience in this, but I'm really curious. So every time you have, I guess, something negative, you kind of want to follow it up with something positive and turn it into something positive, because just because you don't know about something doesn't mean you can't know about something.
Yeah.
And so being curious, I think, is incredibly important, because being curious is how you learn more and how you improve yourself. And so it also shows that you actually have like interest in their company or interest in the topic, because I knew nothing about sensors. I knew nothing about their company overall. Like I browsed their website once and I was like, wow, this website is so complicated, because they have like a million different sensors and cables and whatnot. And so I looked at it and I was totally overwhelmed. And I was like, yeah, I looked at your website and it looks super cool. And like, that's all I had to say. It's totally embarrassing, but sometimes you just have to walk in. You're like, I don't know that much about this company, but I'm interested.
Yeah. What has been your guys' favorite project that you have worked on?
My favorite project was probably, I mean, the racing thing was good experience, but it probably wasn't the most fun thing in my life, just because it was really hard. But I'd say my favorite project was probably my senior project right now. It's kind of fun. We're working on making robotic or remote controlled cranes at the Everett, Washington Boeing facility. I feel like you probably know where Everett is, but I don't, considering you're in Washington. I don't know if you guys do. But yeah, so right now it's like the biggest volume building in the world, and we're designing like the robotic cranes to be integrated into the building and testing the feasibility of it. So that'll be a really interesting project. I'm really excited for it.
That's cool.
So I'm kind of split between two projects, which one project was the one that I told you guys about that I did at work for that kind of like human machine interface, because kind of my way of learning, usually when I do work, is I kind of just work on my own. And then once I get stuck, I try to figure it out on my own. But if I get really stuck, then I actually start asking for help. And so that project kind of pushed my capabilities in that I had to keep looking things up all the time and then eventually get help. And sometimes I'd go for help to like my coworker who showed me it all. He's like, yeah, I don't know how to do this. Good luck. And so I just have to keep looking and kind of like push myself forward. And in some cases, it was incredibly frustrating. Anyone who's done code has been in that situation of like, oh my God, it's clear, it makes sense. There's semicolons everywhere. Why is this not working? And it's incredibly frustrating. But when you actually figure it out, you're like, wow, I am a genius. This thing is like my masterpiece. So that was one of my projects that I really loved. And the second one I did last year with two manufacturing engineers. And so it's this competition called Cast and Steel. And every year they give you some sort of object to make. And so last year was a Bowie knife. There's one restriction on it, which is you have to make the blade of 9 to 13 inches long. So like this is a really big knife. And it has to be cast in steel. And so we worked with a foundry that made it for us. But it was a super cool project because we got to kind of just do whatever we wanted creatively. Like our knife could have been whatever shape we wanted, as long as it had a 9 to 13 inch blade and all the components of a knife. But we also learned so much just from doing, where like the casting people got back to us after we sent them our model and they said, I don't know if we can make that. Could you like change it slightly like this? Because in casting, you have to do this sort of thing to your edges so that they don't turn out bad. And so that way, like we kind of learned because we were like, oh, okay, like we didn't do it right, but we can change it so that we can do it better. And it was kind of through that back and forth of getting feedback that we learned how we can make like a good part.
That's awesome.
And then also now we have like a giant knife at home. It's way too big to use for anything, so it's just decorative, but it's really cool because like we have something to show for our work.
Yeah, that's cool. Why did you guys choose to go to Cal Poly over the other universities?
I'm actually from San Luis Obispo area, so my family only lives like 15 minutes away. But I chose Cal Poly just because, like I said, in 7th grade, I had this Cal Poly engineering class come in to my engineering class, and they just told us about their experiences as Cal Poly students and just like everything they were involved in. And I just thought it was super cool. So I was like, I'm going to do that. And I just kind of stuck with it. And I applied to a couple other universities, but I just mainly wanted to go to Cal Poly.
Mine is a little bit more complicated. Back then I was living in New York, but I used to live in Berkeley. So UC Berkeley was like at the top of my list. I was like, I have to go to Berkeley, favorite place on earth. But my dad talked to one of his friends that he worked with, who's a Cal Poly alumnus. And he said, hey, like you should check out Cal Poly. It's a really awesome school. It has a bunch of hands-on stuff. And so my dad was sold and we went to Cal Poly. And before that, I actually had like a coffee talk with said alumnus. It was like, yeah, like UC Berkeley is great, but you're going to be in rooms with like TAs teaching you up until like your second year. And then finally you'll be with professors. But for the first 2 years, like you're mostly going to get TAs. And it's not going to be that great. But at Cal Poly, they have like a student to teacher ratio. You rarely get taught by TAs. There's a bunch of hands-on labs. And don't tell anyone I told you this, but he also had access to like the admission rates, and manufacturing engineer has a 50% acceptance rate, but don't tell anyone. And so I was like, okay, well, like Berkeley and Cal Poly at the top of my list. In the end, I didn't end up making it to Berkeley, and I made it to Cal Poly. So like I had kind of no choice to go to Cal Poly. But looking back, like over the past 3 to 4 years at Cal Poly, I'm 100% happy with my decision. And if I'd gone to Berkeley, I think I wouldn't be as happy.
Yeah. What recommendations do you have for someone entering the industry?
Basically, when I came to Cal Poly, when I got accepted, right before I told myself that I just kind of wanted to try everything. So I joined like a graphic design class, a computer coding class. Our engineering class in high school was a drone battling class. Literally for the whole year, we just battled drones. Just like a lot of different, I did like woodworking for a while. I tried welding. I tried a lot of different stuff, and I just basically was trying to figure out where I kind of fit in. And I realized that I really enjoyed those hands-on projects rather than coding for computer science or computer engineering. And I just kind of stuck with what I knew and like what I wanted to do. And I just basically say, just try everything. Like it's not going to hurt you. You know, if you don't like something, you can just stop doing it and change your path a little bit. Even in college, people change their majors all the time. Just ask Balthazar.
Yeah. That's also my advice, is just like being really curious and hungry for new experiences. Because like I didn't know that manufacturing was my thing. Like I was like, okay, sure, I want to be in engineering, but there's a million different types of engineering. Aerospace, I mean, chemical isn't at Cal Poly, but like aerospace, chemical, industrial, mechanical, electrical. I could go on and on all day about the different branches of engineering. And so being curious and going out and trying stuff is what answers these questions of, do I like manufacturing or do I not like manufacturing? And in some cases, those experiences might be negative and you're like, oh, wow, I hate manufacturing. And the same way, like during my internship, I was like, I don't want to do sales engineering ever because I'm going to hate it. But even if it's like a negative experience and you realize you don't like something, that's also a huge advantage that you now have, because you know, I don't like this. I can put my time and energy into exploring other things instead of like sitting down on this one idea that I don't like, but it's the only thing that I know. So being able to get more experiences to change your opinion on things is, I think, super powerful.
Yeah. Okay, thank you guys for doing this webinar.
Thanks for having us, Eli.
Yeah,
Yeah, thank you.
thank you. Bye.
It was great to hear about combining interests in STEM and business. I was surprised to find out that it would take Jason only one additional year to get his master's degree. I thought it would take much longer. There is one more very important team member to introduce.
This is Buddy. He's our lead builder. He's the smartest one on the team. He is super talented out. But he does have a short temper. But as you see, he really likes to build the robot. And it's his robot, not anyone else's. He also likes to set up the field, but he ends up eating most of the field, so.
Thank you all. We have friends from Cal Poly. Andrew, Brian, and our team members are here to answer your questions. Please raise your hand or type a question in the chat box and we will get your questions answered.
Thank you all for joining us today. As a private rookie team, we are self-supporting. We are able to do with our supportive donations. If you would like to help us out, our donations link is on our Instagram.
We have another webinar called Inclusivity and Diversity in STEM in January. Watch your Instagram for details.
Thanks for being here today. Accidental Success appreciates your support. Have a great afternoon.
Bye.
Bye.
We're going to go ahead and do the question and answer session now.
Do I need to be good at math to succeed in the STEM field?
Is this just like an open question arena? Like, do any of us answer? Okay.
Yeah, anyone.
I feel like math is just kind of a small part of it. It's just mainly problem solving. So if you're a little better at physics or chemistry and stuff like that, that's good too. But math kind of is fundamental. It kind of ties back in. But if you're not super good at it right now, chances are you might pick it up better in the future. I mean, you guys are just kind of doing what, like algebra, or no, not even, yeah, algebra, or geometry type stuff. Yeah, so you got a ways to go. You can figure it out.
I'll also answer that question a little bit. I think that being comfortable with math and problem solving is important, but also everyone kind of has their own strengths. The classes I've taken are beyond what you guys have learned so far, of course. But I feel like everyone kind of has their own area they like a lot better. Like, for example, for me, I find physics a lot more interesting than kind of like pure math. And so I feel like having an interest is more important than kind of being good at it, because if you naturally like something, you're going to be more engaged in learning it. So you'll learn it faster and you'll become better at it a lot quicker. So I feel like being interested is more important than being like just good, because naturally good only carries you so far. Being interested in it means like you'll put in the time and the energy, and you'll want to put in the time and energy, and it won't feel like a chore to learn it and get better at it.
Very true, Balth.
This is Brian. I'll add that I don't think you have to be good or great. Kind of what Balthazar was saying is, for me through college, I had to, of course, take all the calculus and calculus-based physics, differential equations, things of those that you don't really reflect on and you don't really use. I didn't use it in my career. It was, the theoretical side of engineering. I don't look back on it fondly. It was just one of those things you had to do in order to get through your degree. But applying it in the physics-based, I thought was very interesting when you got into kinematics, motion, optics, electromagnetics, all of those things I thought was really cool to be able to apply math to.
I do love the part where Buddy was introduced as our team mascot.
You guys have any like general questions for us too? It doesn't have to be like school based, just like fun stuff.
What is the biggest obstacle you've overcome in your STEM career?
Biggest obstacle? Oh man, probably a couple classes have been pretty tough. I'm not gonna lie, but nothing's like not doable. You can just kind of keep at it. But like obstacle wise, I'm a part of the racing team at Cal Poly. I think I mentioned that in the video, and there's some pretty tough problems that you have to face. But I mean, you have a pretty large group of people, so I mean, you guys kind of just get it done in like clubs and stuff. But yeah, kind of like you guys. I guess you guys face your own problems in robotics, but yeah, anything's possible. Keep your mind to it.
I think that beyond kind of like the typical problems of like, oh, this homework is hard or stuff like that, I feel like developing people skills is a tough challenge. Engineers naturally seem to be kind of a little bit more introverted and not really want to talk to other people or kind of do their own thing. And sometimes putting yourself out there and like talking to other people can be a little challenging, but like I said before, like everyone kind of has their own interests and everyone's really good at one particular thing that you might not be so good at. And so being able to realize that and then also kind of put yourself outside of your comfort zone, go talk to someone, say, hey, like I noticed like you're super interested in, I don't know, like 3D printing. Could you teach me more about this, or can you help me with this? And so it's like being able to talk to other people to get help from them. Because after all, like we get more work done together. Like the moon landing, that didn't happen just because like one person worked on it by themselves. It was like a collaborative effort from hundreds, maybe even thousands of people that work together because each one brings their own piece of the puzzle to the table. So being able to work with other people, even if they're not very like you, is I think like something that's really challenging, but something that you can develop better over time.
Would you guys maybe be interested in hearing maybe some of the companies that me and Balthazar have been talking to? Maybe just some insight? Yes, no? Nods, shakes.
Yeah, that'd be actually really interesting.
Okay. Let's see. So right now I've been talking to some companies like Lockheed Martin, who does like space stuff. I don't know how familiar you guys are with some of these companies. My senior project is through Boeing, actually. So I'm going to be testing some robotic crane feasibility in there. If you guys know Everett, Washington, it's like the biggest volume building in the world at their facilities, which is pretty crazy. So we're going to be doing that. But I really want to go back to Lawrence Livermore, hopefully this next year, and work for them. That's like my main go-to, and I've been talking to my boss, so hopefully I can get something worked out. But yeah, there's a lot of, I kind of just want to do like some technology development, just kind of like be a part of the next big thing. Hopefully do like some like SpaceX, Tesla. That would be cool. I don't know.
Keep saying SpaceX. You know, there's Blue Origin too.
Wait, what?
You keep mentioning SpaceX, but you do realize that Blue Origin is right here on the West Coast as well, right?
Oh, really? Yeah. Rorina was telling me about Blue Origin. Sounds pretty cool.
If you can see in my background, I'm a little bit starting to get into the space nerdy stuff, right?
That's cool.
Yeah, I think you missed that part. Yeah, I actually work at Blue Origin.
Gotcha. No wonder why Arena's all interested. She was hyping up the company for me. I was going to talk to you guys actually at the SWE fair, but that was pretty interesting.
Yeah.
I don't know if Arena told you about that. It was a little hectic, but yeah.
So did you guys watch the SpaceX launch this morning then?
No, I was playing basketball.
I
It sounded cool though.
I was working on my senior project, so I've been productive all morning.
How is robotics, or how is a robotics project decided in the club?
Oh, that's bigger. Oh, like our club?
Sorry, never mind.
No worries.
How has COVID impacted your career?
That's a great question.
Do you want to take it first, Beth?
Sure. My career, I guess I'll talk about like how it impacted my internship, because as a student, it kind of just shifted all my classes online, just like you guys. But one thing that my company did is, so my company would sell automation. So they kind of sell like sensors and then wires and essentially like circuit boards that make all these important decisions based off sensor data to, like, I don't know, turn like the thermostat on. And so one that was really tough for the company is the branch I was working in, most of the people there are sales engineers. So basically they call a company and say, hey, like, how's it going? I hear you're working with the milk industry and you have to keep your milk a certain temperature to pasteurize it. I'd like to sell you like whatever sensor because I think it would improve your factory. And so typically they would also end up going to said factory, seeing what kind of systems they have in place, and convince them to buy something. The difficulty though is with COVID, they had to stop all travel because otherwise like you're putting your own employees at risk. And so one thing that happened is basically like everything kind of had to shift online, and they had to figure out new plans and like, how do we talk to these people and give them kind of the same experience they would give them in person? How can we make our PowerPoint slides more convincing? How can we give them like a demonstration of what our systems are capable of? And so fortunately, I was still able to work in the office, and we'd meet in the office, masks and everything. But we had a lot more meetings about sending convincing emails, following up on leads, stuff like that. So one thing that kind of like became, we did have some visits, but essentially in like this COVID world, we've been placing a lot more emphasis on when is it worth actually going to a factory and taking that risk versus should I just stay at the office where I don't have to waste time driving somewhere, and I can kind of put work more effectively into work.
For me, for my company, I got accepted for my internship before COVID, and I was like, yes, this is my time. And then all of a sudden, it was actually like 2 days before I was supposed to start my job. My boss, she called me and she said, oh, so I just wanted to make sure you got our email maybe 2 months ago. Your internship's not going to be happening this summer, maybe next summer. And I was like, oh my gosh, like I was expecting to go in to work. I was like ready for this job. And then finally, she called me back and she said that she felt super bad because I guess she accidentally forgot to send me that message. And so she connected me with some other mentors in the company, and they moved me to the nuclear department instead of the engineering department. And that's actually how I got in there. And I was really thankful that I just had an internship, but I feel like I picked up a lot of cool experience that I actually wouldn't have gotten during COVID. But it kind of wasn't ideal just because, you know, I wanted to be in person. I'm like I'm a person who like needs to be like in the classroom or like in a room doing projects with other people, talking with other people, collaborating. So that was a little difficult on me, but it kind of helped me a little bit grow because I was online kind of researching how to do my job almost, since, you know, shooting an email to my boss, maybe it would take a day until he'd get back to me. So it kind of made me more productive as a worker. It kind of helped me out in that sense, but really kind of disappointed I didn't get to be on the factory floor in the lab, but hopefully things get a little better by next summer and we'll be able to go back to work. I don't think anybody's having the best time at work right now being remote, but things will be better in the future. We'll see.
Yeah, so for us, at Blue Origin, they've pretty much put a lockdown on anybody going into the office unless you actually work on the factory floor. So for me, it didn't change very much though, because I have the company laptop. I still have my 3 monitors. I'm sitting here at my office right now. You're looking at my office. This is in my house. A lot of the communications that we do are with our Florida team, and I'm based in Kent, up in Washington. And so most of the time, whenever we had a meeting anyway, we were having to call in, and you'd see 5 of us guys sitting at desks next to each other in the Kent office, but we all had our headsets on talking to each other because we had to talk to 1 or 2 guys that were in our Florida facility. So the dynamic of how meetings and how work gets done hasn't really changed that much for us. It just, when you go to the, if you need to get up and go to the water cooler or the coffee or something like that, you just don't see your buddy there. It's in my kitchen instead of at the office. So there's a little bit less interaction on that kind of a scale, on the personal scale. But overall, for the job that I do, which is finite element analysis, which is really ingrained into doing computers, it's all computer work. I can jump onto a Skype call with anybody in Florida right now or anybody up here in Kent right now and show them what I'm working on via Skype. And it's almost like having them next to me, but not quite. Also, some of the things that we've talked about during the robotics club meetings is that some people will have a question and they'll call me from Florida and they're like, hey, I'm having problems running ANSYS today. Do you know how to get around this problem, or do you know how to do X, Y, or Z? And with the technology that we have now, I'm able to say, yeah, just give me control of your screen, and then I can run their computer remotely. So really, it hasn't changed much of how I personally work. Now it does change how the company dynamic works, because like I said, we can only have so many people in the buildings right now. So like on the factory floor, they all have to spread out. Only one person can be at a CNC machine at a time. You can only, like, after every use of the machine, that whole workstation at the end of the shift has to be completely sanitized. They're making sure that they're doing as much as they can for contact tracing, things like that. So it's almost a little bit, I don't know, it's just kind of like imposing with all these restrictions and stuff that are on certain people. But overall, the work is still getting done. It's just a little bit different dynamic is all.
Yeah, this is Brian. I'll add on to that. So what Andrew said, it's pretty typical for Boeing as well. Initially when COVID hit, Boeing has a lot of defense and space contracts. And so that work was deemed critical and continued on. And even now today, we've got our manufacturing for our big aircraft are ramping back up. Our space side has significant wins in terms of what we've won from maybe contracts. So we've got a lot of neat projects that are going on for that side. But if you go out to the factory floor, just as Andrew just talked about, there's just a lot of the physical distancing, social distancing that's been put in place, contract tracing, keeping things clean. And, this has presented yet another engineering problem, right? It's trying to figure out how do you continue forward in this environment, being safe as you can, and make sure everybody's safe, but continue to still build. So this is just thinking of it. It's unfortunate, but it's another thing that we have to solve for, either at home, at work. So it's all very much the same as what Andrew was saying for Blue Origin. My job specifically, so at Boeing, I am a chief engineer for our facility side of the house. So all of our big buildings and all of our factories, I'm the chief engineer for that. So I have engineers all over the country that are part of my organization. So I can do a lot of my work remotely. I'm urging to get back on site. I miss that part of it. I miss being back on the factory floor talking to people. That part of it I do miss, but able to still work pretty effectively virtually with the team.
What does the average day at your job or in school look like?
I can go ahead, I guess. Let's see, for school, I feel like freshman year was very different actually from now. Considering starting off, as we were talking about, we were starting out with your calculus, physics, sciences in general. And I just remember getting, waking up in the dorms. We had like 40 guys on a floor. Everybody's shuffling around. It was really hectic, but really fun. It was just a nice environment. And then you'd go to class like shuffling around with thousands of students, and it was a big eye opener for me coming from a high school when we had 150 kids in my graduating class, so it was pretty tiny. But yeah, going from that, and then basically I would come back, be grinding on some homework with friends, but it was like very like community based. Like we would all help each other out. Somebody was experiencing trouble on a problem, we'd help each other out, try and kind of get through it together. And I feel like that's changed a little bit, just getting higher up in the grades, and also at the same time COVID hitting also. Like I can't really study with my friends much anymore or get that face-to-face action. But now I just mainly, I don't know, I do a lot of meetings online with like SME, with our club. We have a couple projects going on. We're building Thor's hammer this year with our club. I don't know if we mentioned that in the video. It's gonna be like 6 pounds. It's gonna be pretty cool. See how that goes. And yeah, just a lot of like little extracurricular stuff to keep us busy.
I guess I'll go next because we're still on like the schools topic. For me, with COVID, it's kind of changed, but like kind of my typical schedule back in like freshman, sophomore year, non-COVID times was really structured, where essentially kind of like my morning was super packed with work and classes, and it was a schedule where like I'd be up at 7 a.m., sometimes even earlier, and then I'd just like be working the entire morning. And actually this summer, like my internship kind of brought me back to that, where I would start work at 7, 8 a.m. and then I'd end early around like 4:30, and I'd have like the rest of the afternoon to myself, which I really like that schedule of kind of just like getting up early, getting work done, kind of like just being on the clock. But with COVID, I've kind of slumped back into an easier schedule that's kind of just self-gratifying of I get up when I want, I do work when I want, and my advice is don't do that. Stick to something that's scheduled, and like you have lunch at a certain time, you work at a certain time, because while I'm loving not working when I don't want to work, it's also awful for my productivity. I've been going to bed too late. I'm not doing assignments. I mean, I'm doing assignments before the due date, but I'm doing it when I feel like it. So I end up kind of running late on the schedule I should be on. So don't do that. Don't give in to laziness. It's good to sometimes take a day off, but don't do that. I'm enjoying it, but I feel awful about it.
Good point, Balthazar. I am a type A person, and so I like to be planned and kind of things consistent. So even being here at home, working virtually, I don't put my slacks on in my dress shirt anymore, but I'm certainly getting ready. You feel like you got up, you're in the den, you're ready to do your day, and you make it part of that continued process. I think the question was more around what's your typical day?
Yeah, what's typical
So
day?
for me and my job, it's several different things. It's at the position I have, it's kind of like running a business now. So you're trying to think about business management. You've got big goals, big strategies you're going after. So a lot of what I'll call my operating rhythm, my day-to-day, or how my week is set up, it's about measuring the performance things, maybe what we call key performance indicators or certain metrics that show if you're getting towards achieving a goal. And it's helping teams work technical problems. So we've got technical review boards that we help lead to go solve things across the country. But it's a pretty consistent operating rhythm every week that I have. Maybe not as interesting anymore because of where I'm at in my job, where you're not maybe touching product every day or solving engineering problems, but that's a little bit about me.
What misconception did you have before starting your career?
I think one misconception is it kind of goes back to the first question about related to math. And this is different for every job. So I'm generalizing here when I talk about it. You have to go through the math as part of your curriculum, right? And it's just the thing that you have to do. But like I said, I haven't looked back on differential equations since I took the class. So just just push through. So one misconception is that depending upon the job you take, you're going to have just a ton of math. Yeah, there's math, but it's not like it's this scary, yeah, what are we going to see? Perfect. I love it. Is that differential equations for, this is a good one. But misconception was that all the stuff you're learning in school, and I like to hear about the Cal Poly team here because they're doing manufacturing engineering, which is really kind of fun because you're learning how methods and processes where maybe with Andrew and myself being an electrical engineer, I learned a ton of theory of things that I have never applied, whether it be digital circuits, analog circuit design. I just had to get through it. So misconceptions was it was really hard, but it didn't necessarily frame what my job was ever going to be like in the future.
I'm a little early in my career, but I think I can kind of answer the question in terms of like my career at Cal Poly as like learning engineering. I got into Cal Poly, and like Cal Poly is great because it puts you in like labs on like the first day and you get to try machining and all that. And so I show up, I talked about this in like the like interview with Jason. And like I see these people like Jason who have been like working on go-karts and whatnot, and like it's super hands-on machining and all that. And so I'm like, do I want to do this? Like I've always been kind of more like software related. And then in high school, I did a little bit of like computer science. And I was like, oh, like coding is like totally not my thing. I don't want to be a software engineer. But at the same time, I also kind of enjoyed like a little bit of software. And so I thought it was like kind of either one or the other. But through kind of like trying out classes, my internship, I kind of discovered like engineering isn't cut and dry. You're either totally machining or either totally software. And I kind of found a place in automation, which is a little bit of software, a little bit of more engineering, like machining type stuff, where you kind of get to pick and choose a little bit of what I like. And so that's one thing that I kind of like discovered about engineering is that there's so many disciplines, but even if you're an aerospace engineer, an electrical engineer, you can kind of find a place in an area that you like that's not going to be purely electrical or purely aerospace or purely manufacturing. And so, for example, like jobs that I'm looking at are solutions engineer, which that's kind of more software related than really mechanical or manufacturing. So it feels like there's a place for everyone, even though it might not seem like it at first.
Yeah, to build on that, the misconceptions that I would say I had is about myself and thinking I knew what I wanted to do. And I mean, it goes right along with what Balthazar is saying is, if you look at it, I thought I wanted to be a veterinarian and I wanted to go into animal science at Texas A&M. And then I found out that that was not the course for me because the subject matter was just a little bit more involved than I wanted it to be. And so I decided to go into the engineering track. And so in the engineering track, I went for a naval architecture type degree. And I started my career in naval architecture. Well, 3 years into that, the next shiny thing came along, right? And so somebody said, hey, we're doing oil and gas on the subsea, on the seabed. And they said, we could really use somebody who has the knowledge of naval architecture to help us do the installations because we don't know how our ships are actually moving. Can you help us do installations on the seabed? So, I ended up doing that for several years. And then somebody else said, hey, I'm going to leave the offshore oil and gas industry. There's a new startup company. They've been doing this for, 15 years or so that's doing reusable rockets. And they just landed their first rocket a couple of times this past year, and that was in 2015. And so he said, I'm leaving to go there. Well, I'm sitting here going, okay, oil and gas, it was starting to go on the decline. And so offshore, it's like, nobody wants to spend that kind of money on offshore infrastructure if it's not going to be a viable resource. And so I started looking at Blue Origin as well. The guy who came up here first out of our company in the oil and gas industry, he was the first one. He ended up, I think I was number 5 or 6 to follow him up here. And then we ended up with like 8 or 9 people from the Houston Offshore Oil and Gas Company now working inside of Blue Origin doing their testing and operations facilities. So the hardest thing is staying focused. And that's the biggest misconception is just like Balthazar was saying, is that you can't just be in one thing of engineering, because as an engineer, you get asked to help out with so many problems in the industry. Like for instance, some of the stuff that I'm working on now is structural, yes, right? However, it's going to be exposed to extreme heat due to rocket engines. Well, I'm not a material scientist, and I'm not a materials engineer, so I don't know how that's going to affect my structure. That means I have to go talk to a material scientist or a material engineer, and I have to get their help and their buy-in. And so we have to start learning between disciplines. So we have this cross-discipline communication going on. So in the end of it, I know a little bit of naval architecture. I know a little bit about subsea engineering. I know a little bit about structural engineering, well, a lot about structural engineering. I know a lot about finite element analysis. I know a little bit about thermal. I know a little bit about material sciences. So yeah, that's the biggest misconception, is that you're going to go into this one track and that's all you're ever going to do, and you're going to be pigeonholed. In my experience, that's almost never the case. You're always brought in as a problem solver. As an engineer, that's what you do, is you solve problems. And if you don't know the answer to that problem, then you bring it upon yourself to actually go find that answer, or find the person that knows that answer. So yeah, so there's the answer to misconceptions in a little bit more than a nutshell.
Quickly, as a side note to kind of bounce off of that, back when I was like a freshman or sophomore, I was incredibly jealous of all kind of the engineering students who knew like, oh, I'm totally a mechanical engineer, or like, I'm totally an electrical engineer. I know exactly that's what I want to do. And so I used to be so jealous, because it's like, wow, like these people know exactly what they want to do in their life. Like, I wish I had that kind of foresight. I wish I knew where I wanted to go, because right now, like, all I have is just like a list of questions and they're unanswered. But at the same time, I kind of realized that's actually more of a gift, because you're more open to trying new things, because you need to answer those questions. And so those people might think that electrical engineering is the best thing ever, but actually they might like materials engineering better. But since they're so determined that that's their favorite thing, electrical engineering, they're never going to go check out what materials is all about. And so kind of like being unsure of what you want to do enables you to be able to put yourself out there and be like, I'm going to try this new thing. We're going to see how it goes. And maybe I'll love it, maybe I'll hate it, but we won't know until we try.
Then my answer is a little shorter. I just I feel like in middle school, I'm pretty sure like Iron Man came out. I was like, Tony Stark, like that's crazy. And then I just kind of wanted to like do that, and I was like, what job is that? And then I figured out like engineering was the closest thing, and I was like, let's do it. And then I just kind of stuck with that. I don't know why, but it was funny because I'm the only engineer in my family, or about to be engineer. And then my family, they told me that, like, Jason, like engineering, that's a lot of math and science and stuff. You're gonna be like kind of like seen as like a dork. And I was like, no, like this is like what I want to do. Like I think this is like the best option for me. And I just kind of stuck with it for the past, wow, what's it been, like 9 years I've been on this track. So yeah.
Being a dork is good.
All right, well, thank you so much, everyone. Thank you especially to Andrew, Brian, Jason, and Balthazar. This was incredible. You guys are amazing. That's all we have for today. And if you want to learn more about our team, you can email us. Go to our YouTube. So this whole webinar will be posted on YouTube. And then you can also check out our Instagram. And if anyone wants to donate out there, you can donate on our Instagram as well. So thank you so much, everyone. I hope you have a great rest of your weekend. And yeah, thank you.
Thanks, Arena.
Thank you.
It was awesome getting an invite.
Thank you.
Thank you. It's
Bye.
amazing.
Thank you. Bye. Have a wonderful day and weekend.